The objectives are going to be to learn about variable charged cations, what they are and where they're located on the periodic table, and also, given the ionic formula, can you name the ionic compound? Right, so the two things we're looking at today are variable charged ions and also naming ionic formulas, but really specifically naming ionic formulas that have variable charged cations within them. Take a second, guys. Try and name this. It's something we've learned in the past. You've seen this before. Can you name this compound? MgO. Press pause, name it, and see if you get it right. The name of this is called magnesium oxide, and it's kind of cool because I want you to remember that we have learned this before, and we are going to use the skills that we have learned in the past of how to name ionic compounds. We're going to use them again today. So the first element is named first, the leftmost element on the periodic table, magnesium, that's named first, and this is named second, and oxygen gets changed to oxide. Alright, cool, dudes. Here we go, name this one, guys. It's CaF2. So I have given you the formula. You have to give me the name. Press pause, take a shot at it. The name for this is going to be calcium fluoride. That's right, fluorine gets an IDE ending, so it's calcium fluoride. Awesome, guys. So far we're looking at the periodic table, and we've identified the number of valence electrons. We've seen the valence electrons are 1, 2, and we've seen that going all the way over here to 8 at the very far side. We've also identified the charges that come with these guys. But one thing we haven't discussed yet is a certain section of the periodic table. In the middle here, we have not looked at this D block, and also the elements that are underneath the staircase. I've been purposely dancing around them and avoiding them for a little while now. Now the first column we have is a 1 plus and a 2 plus, and the charges are at the top of every column. And you'll notice we have not discussed the middle of the periodic table. And there's a reason for that. Because in the middle of the periodic table, those atoms very often have more than one charge, and they're known as variable charge cations. Cations with more than one charge. For instance, copper can have a 1 plus or a 2 plus. Lead can have a 2 plus or a 4 plus charge. Those guys do not have a set charge. So where I go backwards here, and everything in this column has a 2 plus charge, I can't say the same thing about this column here. And I can't say the same exact thing about this column either. They don't all have the same predictable charges. They have more than one charge, which is why they're known as variable charged ions. Specifically in this case, they're positives. They're called variable charged cations. One thing we're going to see that's a big theme in all of our ionic compounds is that the total positive charge must always equal the total negative charge. And if you don't totally get this, you'll see what I'm talking about in the next slide. Question I want to ask you here is, what is the total negative charge on the oxygen atoms? Now, if you're using your periodic table, or just rewind this for 2 seconds, you'll see that oxygen has 6 valence electrons, which gives it a 2 minus charge. And each oxygen atom here has 2 minus charge. So therefore, 2 minus plus 2 minus gives me a combined 4 minus. And what I had said in the last slide was the total positive charge has to equal the total negative charge. So if I have a 4 minus charge on this side, my positives must also have a 4 plus charge. So what I want you to see here is that my negative 4 was distributed over 2 atoms, and they each got half of that. Well, in this case, my positive 4 is going to be distributed only over 1 atom. So therefore, the charge on this has to be 4 plus. Tin is located below the periodic table's staircase. It is an element that has more than one charge. What you have just determined by doing this is the charge on tin. That's all it took. It actually was identifying the charge on my negatives, my anions, adding up those two charges, became 4 minus. I made that 4 positive because ionic compounds must always balance out their positive and negatives. Now, I distributed that 4 into just one atom. That's where I got my 4 plus charge from. We're going to learn now how to name ionic compounds. And one of the things you're going to see here is that it's different from our introduction slides where we named like 2 compounds. This should be new right here to you. Okay, copper 2 chloride. And these are Roman numerals. This is the Roman numeral 2. And what that is, 2 represents the charge that's on copper. Now I want you to remember, we're dealing with variable charged cations. Okay? In order to identify which ion I'm dealing with, am I dealing with a +1, a +2, a +3, you have to state that. And inside the parentheses now, you're going to use Roman numerals, and they're going to tell the charge on the metal or the cation. You'll get the hang of it. Once again, though, this is only used for ions that have more than one charge. Okay, so in our last slide, we saw that this was a 2-, this was a 2-. Altogether, we had a 4- charge. Over here, we're going to have a 4+ charge, but that's distributed only over the one atom, so therefore the charge was 4. What I'm trying to tell you is that the charge on my individual ion on tin has to be a Roman numeral 4, like that. That says tin has a 4+ charge. And I name this tin Roman numeral 4 oxide. Okay, traditionally you would look at SN3N2 and say this is called tin nitride. But in this case, tin has more than one charge, and it's our job to find it out. If I look at my negatives here, nitrogen has a 3- charge and a 3- charge. And that is a consistent negative charge. It doesn't have a variable charge. So we can actually start with nitrogen. So each nitrogen has 3- charges. So 3- and 3- gives me a big picture look here of 6 negatives. Well, I'm going to let you know that you need 6 positives as well. They have to always balance out. Well, just like my 6 negative was distributed over 2 atoms, my 6 positive is distributed over 3 atoms. So therefore, each one is going to have a 2+ charge. How do I name this crazy compound? Well, SN3N2 is named tin. That is what goes inside here. Tin 2 nitride. Excuse my pen there. It's flying. I'm going crazy. Okay, guys, here we go. Next one. Something that's kind of helpful for you to do would be to take 2 seconds, press pause, try to name copper oxide. And we need a Roman numeral here. The Roman numeral is going to be the charge that's on my individual copper. So press pause. Please check it out. I know in the past I've given you charges on here. Please now use your periodic table to identify the charges on the non-metals first. Once you get that, add the 2 charges up. You put it over here, and you write down the total charge. You go over to the other side, on the left-hand side, make that a positive charge, now distribute it within. Press pause and give it a shot. Alright guys, oxygen has a 2- charge, a 2- charge. I'm going to add 2- plus 2- to give me 4-. Over here, that must mean this is 4+. I distribute that over the one atom inside here, and my 4+ goes right there. Copper 4 oxide. And I want to let you know, one of the things that a lot of students kind of do is they say this, I'm going to reverse these numbers, and that's how I'm going to get my charge. But I want you to see that you would have reversed a 2 up here, and that is not the correct answer. So reversing the numbers in the bottom does not always work, so please don't try that. Okay, we got another copper this time. So last time the copper had a 4 charge, this time it's going to have a different charge. Press pause, try to name this guy. Once again, you're naming it with the charge of my copper right there. Fluoride is a 1-, Over here, the negative charge is 2. I need a 2+ to balance that out with. That's distributed over one atom. Therefore, this is copper, not 4, but 2 fluoride. Okay, another big one here. I got 3 zincs and 2 Ps. It's going to be called zinc something phosphide. Start off with the non-metal, the phosphorus, work your way over to the zinc. Press pause, give it a shot. That's supposed to be a 3-, that's right there. And I'm supposed to have a 3- down here too. Total negative charge in this case is going to be 6-. I need to balance it out with a 6+. Now the 6+ this time is distributed over 3 atoms. So 6 divided by 3 gives me a 2+ on each one. And here we go. Yeah, my pen is getting a little crazy on me tonight. So the charge on my zinc is going to be 2. Zinc 2-phosphide is how I name it. Here's another one for us, guys. Let's check it out. Sulfur is a 2- charge. If I add them all up, I have a total negative charge of 6. Just like the last one, too, actually. I must have a 6+, and that's distributed over 2 atoms. So this one now is going to be a 3+ and a 3+. So really, it's 6 divided by 2 is 3. So this becomes silver 1,2,3 sulfide. In station 7, we're looking at 1 lead atom and 4 fluorines. Each fluorine on the periodic table has a charge. Press pause, work it out, name this compound. Now each fluorine does have a 1- charge. That gives me a total negative charge of 4-. I need a 4 positive to balance that out. That 4 is distributed over this 1 atom. Therefore, as you guessed it, the charge on this must be a 4+. Roman numerals is IV. Boom, there we go, guys. Good job. Hope you got that one right. Okay, guys, I want to wrap it up now. This is kind of more of what you'd see on a test or a quiz, and I'll give you PBP, and I'll ask you to name it. And you're going to say that's lead something phosphide. Inside here will go the charge on lead. I know this because lead is located in the middle of the periodic table or under the staircase, which tells me it has a more than one charge. There's an atom, and there's an atom, because right now I have 1 atom of phosphorus, 1 atom of lead. Let's call this P, let's call this PB. Phosphorus in the periodic table has a 3- charge, therefore the total negative charge is 3-. I need a 3+ charge over here. That's distributed inside this 1 atom, so lead is a 3+. So it's lead 3-phosphide. And the last one we're going to look at today is this one. I have 2 cobalts and 1 oxygen over here. So this will be called cobalt something oxide. So oxygen has a charge of 2-, and that's where we'll begin. Oxygen has a 2- charge. There's 1 of them. Each one of my cobalts, I have 2 of my cobalts. I got that from this number right here. I need a 2+ charge, and therefore 2 distributed over these 2 guys is going to give me a 1+ and a 1+, and this is going to be cobalt 1 oxide. Anyway, guys, that concludes today's lesson. We learned how to calculate the charge on cations that have more than 1 charge. We learned where they're located on the periodic table, and finally, how to name ionic compounds that use and involve variable charged cations. Okay, guys, hope it was helpful. Have a great night.